Good evening, London. It's amazing. Past 4 p.m. and I have a room full. I am already honored. Thank you so much. So what we're going to do is we're going to pretend that we're happy because we don't know what happens after the talk, but at least right now we're happy. We're going to take a picture. All right. Wow. I'll probably have to do a panorama. That's a lot of people. Standing room. That looks even better. Let's get them before they sit down. Perfect. Awesome. So that's my email, and that's my Twitter. If you love the talk, tweet about it. If you do not, email me. Here's some information about me. These are things you never want to do these things. If you want to be a billionaire, do not do any of this, right? All you need to do is go to school and then drop out, because every billionaire does that. Drop out in the last semester, and you're definitely going to be a billionaire. Do not follow me. I do work. We just acquired another company, Kasten, and if you're tired of working with non-technical recruiters, give us a call. I'm the CTO there. I also own Chander Dhall, Inc. It's not a one-person company, just so you know. It's been challenging to prepare this training because this is 1 hour, and we usually do a 2-day training on this subject, so bear with me. Hopefully I don't get a lot of red cards. I'll buy you dinner if you want to give me a green card. Steve Souders, one of the most phenomenal people out there, a lot of good work on web performance, says one really good thing. Great developers know why things work. So we're really going to focus on the whys, because it's really easy to understand the hows. Hows, in fact, you can Google, Stack Overflow, and everything is there. But the why is important. Today's agenda, we're going to try to understand web performance and then identify bottlenecks, and then go back and try to see if we can make it faster as long as we have time. And then you have minus time, and the while loop continues. So before we get into the tips, let's see some code. Here's an example of a Fibonacci sequence. And is that good enough? Is the font size good? Working? Perfect. Just kidding. Making sure you're not sleeping yet. You will sleep by the end of the talk, but at least not yet, right? So here's a Fibonacci sequence of 40, and all I'm doing here is getting the start time and then the end time. And if you run this, I actually have it open right there. So you see the time taken in milliseconds is about 1407, and the count is pretty big. It's a really big number. I'll show you the code in a second. Before that, we're going to change this to the fast algorithm. Run this again, and you see the time taken in milliseconds is 2, and the count is only 39. So let's look into the code. So this is a very simple Fibonacci sequence. You've got 0, 1, 2, and that's how it continues. So what you have to do is kind of see this as a recursion, and that's how it works. Now this is not just JavaScript. It's going to work the same way in any other language. But we're doing a wrong thing here. We're doing recursion. And recursion's adding a lot of overhead in our code. So there's a technique called memoization. I'm not going to get into a lot of detail there. But all you're doing is, if you already know the Fibonacci sequence, or if you know the value of it, you're adding that in your memoizer right here. And that's your array, and you start adding those values. So all you need is for 40, this executes only 39 times. Whereas in the previous case, we saw it took a while. So whereas it was like 2 milliseconds, the other one was more than a second. And that's a huge difference. It is just a small change in your algorithm. We're not going to get into a lot of details in algorithms because you know how to figure that out. That's easy, but it just tells you that in JavaScript, this is an expensive operation. Let's take another example. A lot of times I see this in code everywhere I go. It's good to use underscore because underscore is faster, but if you use underscore in the wrong way, you can get in trouble. So one code that I see all the time is this. Here's a for each, which is more like an underscore each. Underscore is just a library that does certain things better and faster. This is more like a for each, and it says if value is 5, then say exists is true, and then console.log that particular value. Now, if you were to see the result of this thing, you can see that the value found was 5, and even though I have a return statement, I still go 6, 7, 8, 9, 10. Now imagine a list of catalogs on a big Fortune 500 company. Imagine your product list. Imagine any other list. List of your users. Would you really want to go all the way if you already found your user? Let's say you have 10,000 users in the list, and you found the third user, which is exactly what you wanted. Do you still want to loop through the entire loop? And this is a common mistake in a lot of JavaScript code that's out there. A lot of big corporations, a lot of other people have code like this. A good solution is using something like this, which is .every, which is also a part of underscore, and you can use this and say return not equals to 5, and I'm going to go ahead and comment this. I'm going a little fast on this because this is stuff you know, because there's a lot of good stuff coming. Run this thing again, and you see it's got 1, 2, 3, 4, 5. A lot of times when you go from .NET or Java to JavaScript, you assume it's going to work the same way as your other languages would. But JavaScript was a language that was created to make good and smart people feel like they're not smart anymore. And they did it right. They got it right. They did a good job at it. Here's another thing which is important, is a lot of times we make this mistake of having dynamic scope without realizing it's dynamic. So for example, in this case, we have a function execute, which is getting some kind of dynamic code that eval is going to execute. Now this looks pretty good, and for the most part, we'll always get back the window object, except something like this, where someone might send in code that already overwrites the window object. So in case number 2, window is just a string. And now I won't see that, right? So this is dynamic code. And the problem with dynamic code is it's more expensive. So if you use with statements, you're going to see that. If you do try catch, the moment you get to catch, EX or error, whatever is part of catch is also dynamic. So that's another problem. Evals are good only in a couple of cases. Everywhere else, you'll see that they are a problem. Dynamic code in general is a problem. All right, back to PowerPoint, because that's what we love. Are you here for code or PowerPoint? We're going to do both, don't worry. So some JavaScript tips. Usually you're better off with accessing a local variable or member over something that's part of an array or a bigger object, because that's going to be faster. And then you also have location or href. It's actually going to be faster to use this over this, even though they are the same things, because you're adding a global scope, and then you're going all the way up, and then getting to that value. Now, a lot of this does not make much difference nowadays, because you have browsers that have their own engines, and they're optimizing this for you. So a lot of times when people go, I want to make sure that my performance is great, do not spend that 80% of the time without already knowing that this is already supported in a browser. So if you run this thing 1,000 times and you're only getting 1 millisecond benefit, it's probably not worth it. Why do you want to avoid with? The same thing we talked about. Every single function is more like an object in memory, and that object has a scope chain associated with it. When you use with, what happens? You actually create another set of variables in memory, and now you make it part of the first scope chain, which actually talks to the second scope chain. So it becomes slower. Again, the dynamic part of it. So anytime you use with, you know that you're slowing down just a little bit. This is important. Amazon says that an extra 100 millisecond of delay on their response time can cost them 1% in sales. And Google says 500 millisecond increase in latency, and that's just latency, which you can't easily change that much, causes the traffic to drop by a fifth. That's billions of dollars if you look at it that way. And that's a huge, huge, huge problem. So what are we optimizing at? If I were to ask you, what do you want to do? What's the response time that you're looking at? A lot of our clients try to achieve something like 250 milliseconds. And there's a lot of things to be done to get there. And it's not just JavaScript code. There's a lot more other things associated with it. Here's a study from FT.com. It's a very recent study. They did it last year, Financial Times. What they did is they intentionally slowed their website. And what they found out was that the pages per session kept dropping. So the same users were now reading less articles. If you were to see more detail, page load time, here's a 7-day impact, and that's a 20-day impact, 28-day impact, and it's about 7.9%. That's huge loss in viewership later, and that's going to actually they're going to lose customers later. And if you want to see what happened in case of mobile, tablet, and desktop, the study's online. You should read about it. Very good insight into how a user interacts. And the difference is not really much. You would think, oh, it was just 1 second. But in 1 second, you are losing your customers. Let's take an example where we talk about performance versus perception. A lot of times I've seen developers, they only go for performance. However, at the end of the day, it's perception that matters more. Let's take an example. This is first scenario. This is scenario number 2. Let's say you've got this. You barely have anything on the page, and then you have just one header pop up, and then you have the entire page in 3 seconds fully loaded. And the second scenario is where you have this one page. You have a little bit of rendering with a header here, which is a little bit more than that one, and then you have half of this, but then it takes you 4 seconds to get the entire page. In this scenario, you're probably better off picking this, because there's a big difference of 1 second. And we just saw that 1 second is very, very, very important. Let's take example number 2. Very similar in rendering, very, very similar. And then in number 3, you've got the entire page. And I'm really talking about the page width. I'm not talking about scrolling down. You still may not have it. But at least this page that a user can see and relate with. And this is half a page, and then you have this full page, right? Very easy. We're still going to pick that one. This is just the mobile view of the same example we just saw. Another scenario where we have 1 second, we've got nothing going on in both of these frames, and then we have a header just a little bit, barely anything here, and then we have these full pages. Which one are you going to pick? Perfect. Top one. Everyone's going to do that, right? Now rendering, partial rendering is very, very important. Another scenario where we have same amount of rendering here, we got some rendering going on here, and then we have some rendering here, and it's 3.2 seconds. Keep in mind, this is completely empty right here, and then you have the entire page. Which one are you going to pick? How many of you are going to pick the first one? Very good. What about, how many of you are going to pick the second one? Completely outnumbered. So everyone, as I can see, 99% of the people in this room wanted to pick the first one. So that's where perception becomes more important than performance. And it's really the difference. It's just 0.2 milliseconds. Oh, sorry, 0.2 seconds in this case. So we'll pick number 1. So 14 rules of web performance. These are easy. This book was written, I think, about 7-8 years by Steve Souders. You should grab a copy. You should read about it. We're not going to get into a lot of details about all this because this is simple stuff. We're going to talk about the improvements on this stuff which have been there lately. Keep in mind those recommendations were written for HTTP 1.1. How many of you are already on HTTP 2? So this actually might apply. We'll talk about HTTP 1 too, don't worry. So one of the most important things to understand is that latency and bandwidth. A lot of times we go, well, I have really good bandwidth. All my customers are above 10 megabits per second. I don't really need to worry about anything, right? If you actually notice, after 5 megabits per second, the bandwidth doesn't make much difference. The increase that you get in your performance is barely any. So latency happens to be actually more important. And I'll explain that to you in a second. Time to reach the congestion size of size n uses this particular formula. So let's talk about this. Receiving window, 128 kilobytes. Congestion window or receiving window means if a sender has to send a message to someone, it says, look, I'm going to send you something with 128 kilobytes. It's going to send an SYN or synchronize to the receiver. And now the receiver says, okay, either I can take it or I'm not going to take it. Depends on how much congestion the receiver has, right? And that's how TCP works. We're going to see that in a second. Then you have a round trip time. From San Francisco to New York, you have 42 milliseconds. From New York to London, we have about 28 milliseconds, right? The round trip time is going to be double of that. It's about 56 milliseconds. So latency is 21 milliseconds. Round trip time is 42 in this case. And then we have segments. One segment has 1,460 bytes. It's a lot of detail here. Do not worry about it. Divide that, and then you get 90 segments. So all we need is 90 segments to transmit this data over. And if I get you the log of this thing, it's about 3.1. Now, this particular thing is more like a roundup. So it's not going to be 3.12, it's going to be 4, right? So in this case, it ends up being 4. So we multiply this by 42, and it's 160 milliseconds. For what? Just 128 kilobyte of data. First time when you connect, even though we just have 128 kilobyte data, that's really barely anything. Just because of the way TCP works, even with something that small, as in a round trip time of just 42 milliseconds, we still took 160 milliseconds. So that's one thing that we have to consider. Now, this is how you can see a three-way handshake. How does it work? You have a SYN or synchronize. It goes all the way to the sender. So this is our, so it doesn't really matter. It could be either ways because it's TCP. Anything could be a sender, anything could be a receiver. So in this case, you get 21 milliseconds, and then you get the ACK. The ACK gets back to you at 42 milliseconds, and then you actually make the real request, assuming it takes about 50 milliseconds on the server to process. Now you've got your bytes, and the bytes are about, what we talked about. So in this case, first thing what's going to happen is 14,600 bytes. They go all the way here. That's about 10x. Now, previously, TCP used to have 4 segments. Now we have about 10 segments. That's why 1460 into 10 bytes can go all the way here. Next time, it increases. It doubles. So now it's going to be 29,000. And then it doubles again. It's going to be 58,000 bytes, right? And then it doubles again. But we don't need that. The double of that number is 116,800. But all we need is 29,200 bytes, so we're going to be able to deliver all this back in about 240 milliseconds. So you see that bandwidth would not really help you as much. It's really your latency. So if you are very close to your client, you would have gotten there way faster. Even with 100 megabits a second versus 10 megabits a second, you're better off if your servers are actually closer to your user. Because otherwise, you're still going to do what TCP does, and it takes a lot of time. So when a lot of people come to me and say, look, I'm having a big issue with my mobile, and I'm like, what's going on? Well, we're having 3 seconds. 3 seconds is our average request time. I'm like, is it on the first load? They're like, yeah. I'm like, are you using 3G? They're like, yeah. Well, 3G control plane could take up to 2.5 milliseconds. It might not actually be your code. You might be better off taking them over to 4G or LTE. In certain cases, you have clients willing to pay for these people to upgrade, which makes sense. A lot of times, you have clients that are actually on Windows XP. Do you have those? We have those in States, and they're making you millions of dollars. You might actually just get them a better laptop or pay for their internet connection. All right, just kidding. So optimizing TCP. Now, how do you optimize TCP? First thing, upgrade your servers, because the last update was made in about 2013, and a lot of people did not really upgrade their servers. One thing you might want to do is go to 10 segments rather than the 4, the previous one. So that's one thing you must do. Upgrade to the latest version. Increase your initial window size, so congestion window size, which is your receiving window size on the sender side. You should increase it. Make it as much as you want. You can also enable your window scaling. It used to be 65,000 bytes, and it's currently 1 gigabyte. That's one thing you should definitely do. Now, what's slow start after idle? So here's what happens. If you are idle for a while, then TCP goes back into an idle mode and then starts slow start again. What that really means is it's still going to go from smaller chunks of data, and then it's going to double it, and it's going to double it. So if you disable it, then you're good, because your next connection would already be taking a much bigger chunk of data. That's what you want to do. So disable this. Makes perfect sense. You can also do TCP fast open, which is a better way of doing it. So now you can have more data. back and forth. Of course, these two are important things. If you can eliminate redundant data transfers, that's where your code comes in. You can also compress your transferred data. Again, you can gzip it or something like that. Keep in mind, most of this is actually related to network. Code is really a very small part of it, at this point of time at least. And then you want to reduce your round trip times. Again, that's something you could do in your code. Be smart about how you're doing this. And then reuse your TCP connections wherever possible. So fetching data using 3G versus 4G, there's not much difference. In fact, 3Gs are getting better too. So HSPA network is getting much better. So when you hear like 4G and you're like, oh, we're stuck with HSPA network, don't worry, because it's also getting better. But the control plane says it might take up to 2.5 seconds. That doesn't mean it's always going to take 2.5 seconds. You can also have 3G connections with less than 200 milliseconds. Totally depends on how congested that entire thing is. So more tips, reduce DNS lookups. This is really bad. A lot of websites I go to, they have for example.com, and it's going to m.example.com. You've already lost 300 milliseconds right there, so you don't want to do that. You can always have a mobile version of it on the same domain, and then try to make fewer HTTP requests. Gzipping is important. If you were to take one thing from the talk, do it, go back home, do it, and you'll see how much faster your entire website gets. Of course, use a CDN. You want proximity, and CDNs are great for that. You don't want your own servers. A lot of times, use them. They're public, pretty awesome. And then optimize your images per device. A lot of times, I've noticed, I go to companies, and what they have is they've got everything going on. So for example, here's this big, large chunk of image, which works on a desktop. And what do? They're going to use the same image, compress it for the mobile view. That's not a very good idea. You want to do it. You want to have separate images for separate devices, because mobile phones are it's not just about space, right? It's about their memory. It's also about their battery. And you don't want to use their resources to do anything with your data. Have your mobile phone do the least amount of work, and you're going to have a happy life. Adding e-tags so that you don't fetch multiple data. You don't want to do that. You want to create versioning. That's where you use e-tags. And then test on actual mobile devices. A lot of times people test on emulators, and emulators are running on a desktop. And a lot of times you're not going to understand what's going on, especially when you want to know what's the effect on battery. There's a study from Pandora. The data that they were sending to like a song or dislike a song was just 0.2%. The data was pretty small, but it was sending beacons. And when the beacons were being sent, it was taking 48% of the battery. So they decided to not do it at that time, because on a mobile phone, the second most important resource is a radio. The first one, of course, the most intensive of all is your screen, because your screen is taking the most battery. But what's the number 2 resource? It's really radio. So what you want to do is not use the radio as much. So you've got the screen, you've got the radio, and in order to save battery, you want to pre-fetch data. What you don't want to do is something like this. You've got a list, and then you go, okay, well, list number 1, here's a preview, click, and the preview shows up, and you make another call to the server. Now you're talking to the radio again, and it's slowing your user experience down. If the preview is small, and you have, let's say, 10 items, bring all of that data. That's called pre-fetching data. A lot of people will be like, lazy loading is the best thing. Not in that particular case. Now, if you have a lot of data that needs to be pulled, well, that better be a next page in general, because it's a mobile phone anyways, and that's perfectly okay in that case. So minimize your data requests, and then HTTP 2. You don't even know you're using HTTP 2 if you are not, right? So for example, Google, Gmail. Gmail has been running on Speedy for a while, and that's really the precursor to HTTP 2. And it doesn't really take a lot of effort. But HTTP 1 had a lot of issues. For example, it wasn't the best protocol to download multiple things, because TCP would only have one connection. And now you can't just have multiple downloads. Could you do things like have a request and response happening with the same connection? You just couldn't do that. A lot of those things are already fixed for you in HTTP 2, and it's also compatible. It's backward compatible. So moving here is not hard at all. So this is really good because they've got binary framing, which actually is faster. It can compress your data. I mean, it's smaller and it's faster. At the same time, you can have request and response with the same session. Then you also can do parallel requests. Now, previously there was a limit, and still there is a limit. I think it was 2 for multiple downloads, and with different browsers, it's 6 and 8 and things like that. But with HTTP 2, you can have a lot of multiple downloads at the same time, which is pretty smart. And then it does header compression. Server push is another really good thing. So for example, you have a client and the server wants to push a lot of data. We don't allow that right now, just because we don't want to overload the client. With HTTP 2, you can do that, but the client has a right to say, no, I don't want this data. So if the server already knows that these are the 54 different files that I want to send to the client, and the client is willing to accept it, HTTP 2 allows that. With HTTP 1.1, there's not a really good way of doing it. And then the last thing is stream prioritization. Just because you're sending multiple resources at the same time, you have to understand that you need to be able to do wait and dependency, so we know on the other side what order these resources were supposed to come to us, as in the client, right? Am I too fast? I'm trying to cover a lot of things today. We can also slow down and cover 50% of it, or you want me to go fast and cover most of it? Fast? Looks like everyone wants me to be fast. Perfect. Can't believe you guys are awesome. This is almost 5 p.m. You should be sleeping by now. All right. So critical rendering path. And this is very important, because it's really the time taken to get to the first render of the page. I'm not talking about the first byte. Time taken to get to the first byte, as we saw, is way faster. But sometimes the first render could even be 5 seconds later. So how does it work behind the scenes? We just talked about the network. So if you are going to HTTP 2, you will not have to deal with a lot of problems with HTTP 1.1. Assuming we got that fixed, we've got HTML, and then we have CSS, and we have JavaScript. With HTML, we create a DOM, which we all know. And then with CSS, we create a CSS object model. And we take these two things and create a render tree. If we have any JavaScript, that's also part of the render tree. But what's really important is not the DOM tree. What's really important is the render tree, because they're two different things. And then we have the layout, and then it gets painted to whatever device you are part of. And if you have to understand performance, all you need to do is understand this particular diagram, and you're good to go. Let's take an example. So HTML, you can do progressive rendering. So the way it works is it gets downloaded, and by the time it's got till here, we're already creating our DOM, right? And this is going on. It might not have even got to the link element yet. So you can see I don't have the right-hand side of the equation. This is how this is going to look at this point of time. The title will show up, actually. And then let's go a little further and assume that we got everything else. In this case, what happens is we get our CSS, which is here. So we got the div, and that says hello world. And we have a paragraph which says hidden. And it's really a display none. So if I were to go back, it has a display none property. So this is part of my DOM. But this will not be part of my render tree, right? Because that's exactly what we're trying to paint. So if I were to go a little further and go look at this diagram, now we have the render tree. And the render tree is going to be just this guy. It won't have this part. Is that clear? So now render tree is really creating the layout, which gets painted to whatever device we're part of. So that's what's happened here. So we don't see hidden, but we see hello world. So tips. Stream HTML, because it's progressive. So what you want to do is let it come down as it is, and it's going to start progressively rendering itself, right? When you're doing progressive rendering, you also want to make sure that you want to do server-side render HTML, because what you don't want to do is have the client-side render your first HTML page, because it's going to take a little longer, right? So the first page, at least, has to be server-side rendered. After that, you can choose what you want to do. Then you have critical CSS. Why do you want it inline? If you read Steve Sauter's book, he actually says that what you want to do is you want to package all your CSS and bring it back together, which is a great idea for HTTP 1.1. But you still want your critical CSS inline, because what you don't want to do is wait forever before your render tree gets populated. Critical CSS is the minimum CSS you need on your home page, right? And that needs to come in inline. It's going to increase the size of our HTML a little bit, and that's perfectly OK. But we're only talking about the critical CSS. Now, keep in mind, CSS also blocks you. So if you got 20 different CSS files together in one CSS file, it's going to wait for the entire file to load, and then it's going to create the CSS object model. Because it's not, because it has to take into account that there could be another file that has some styles that have to be part of the render page. So that's another tip. You might want to make sure that if you have any critical CSS, and let's say it's a couple of files, you might want to just coalesce those 2 files and leave the 18 away to come in later, right? So that's one thing, because we need progressive rendering. Now, JavaScript is important, and this is very blocking. The reason is simple, that this can also change the DOM, and it can also change the CSS object model. So by default, it must be blocking. So let's focus on this part. Now, JavaScript. If you want to make sure that you have something third-party like analytics, you want to make it async. Why do you want to make it async? Because you don't want it to block anything. Now, this will block. So a lot of times you'll see that people will tell you that, hey, take your scripts and put it at the bottom, right here, right? So right before the end of the body tag, which I think is a very good idea for the most part. But what if you have a single-page app? Your AngularJS code, it's not going to lie in here, right? It might have to be somewhere here. So that's, again, part of your critical JavaScript. And it's OK to put it up there. But remember, it's going to block a lot of things. Now, what happens with the async file? It will also execute when it's ready. So that execution will take time. So let's say this is about 120 kilobytes. And you're not going to use it on a home page. But you might use it on a different page in a single-page application scenario. What you're doing is you're also paying for that execution, right? So that's one thing to keep in mind. In this case, we're already paying for blocking, parsing, and executing. It's going to happen. And nothing is going to happen before that, right? So we're making it wait. Now, this is a design question for you guys. And you can take your decision in your own way. In the older browsers, if this is the timeline, this is what happened. External script 1 came down, and then you had parsing and execution, which is taking another, let's say, 500 milliseconds. And then you have another, let's say, 500 milliseconds of download, another 500 milliseconds of execution and parsing, and then you can get these. So what's interesting is they do not even allow you to download anything because it's all blocking. And they're also not doing anything, multiple downloads in this case. This is older browsers. Well, then one fine morning they realized it was not the best thing to do. So what they did was, all right, we're going to get all these, but we're going to wait, and then we're going to execute them. Even though we can get all of them in parallel, we're going to still execute them in a certain order, which kind of makes sense. So you parse them and execute them, and then you have the other things coming down. Now, if you want to play with this, there's a really good resource, Kazillion, created by Steve Souders. So if you go to Kazillion.com, you can say, here's an external script, and then I'm going to put an inline script, external style sheet, an image. Sorry. Oh, you can see it. Something like this, and then say create. And before that, I just pull up my network tab. Wow, that takes forever. That's our Wi-Fi. And you can check the timeline. You can see a lot of these things. So if you did not have a script, then you could have had CSS, and you could have had the image downloading in parallel, which is perfectly OK, right? So look at this, because it'll give you a good idea. We're not going to get into a lot of detail here. Back to our PowerPoint, because we can cover a lot of these. Wow. OK, technical issues. It's not as fast as our website yet. PowerPoint is not as fast as our websites, right? We create faster websites than the PowerPoint. Just kidding, it was a joke. Next time I have a joke, I'm going to raise my hand. So you know it's I'm kidding. All right. So Gmail Mobile, they did a very good technique. They realized that there could be script. For example, you go on Gmail Mobile and you say, OK, compose. And you may not just use it. You might just be checking your emails, and on that page, you might never use compose. So what's the point of getting that additional 100 kilobyte of code and then executing it? So this is what they did, a very smart hack. So they went inside their script tag and commented their code. And anytime you wanted to use it, all they did is get the script tag element from the DOM and remove the comments, and then eval their own code. Now, eval is not good for security reasons, but eval is completely okay for your own code. So that's not a bad hack. But it's interesting because now they're saving time on execution, which is a very smart idea. Now, there's another way to do this too. You could also do script type equals to, source equals, let's say, your JavaScript file dot XYZ. Now you change the extension because the browser is not going to execute it. You can get that in async download, and you change the extension. And then you can change the extension back to JS and execute it when you want to execute it. Especially something that complicated like a Gmail on a phone, you want to create, keep your resources. So there's something called Control.js. You can look at it. Steve Souders created it. Very good library. Does very similar stuff. Now, JavaScript can block CSS. It can block the DOM, so you want to use async. But you want to avoid document.write. In the middle of the page, you do document.write. It's going to block everything else. So if you have to force something, right, that's when it's to be blocked. That's when you use document.write. So if document.write has a picture as part of it, well, then you're blocking the execution. And if you want to do that, only then use it. So you can defer everything except the critical scripts. Everything else can go back to the body tag, which is a good idea. Again, all for HTTP 1. So critical rendering path, let's talk about layout and paint. So this is where you have 60 frames equals to 1,000 milliseconds. What that really means is one frame should be rendered in just 16 milliseconds. Now, how does that work? In order to get a frame rendered, really what you have is your code, and then you have garbage collection, then you have layout, and you have paint, not necessarily in that order. But you really have about 10, 11 milliseconds because the rest of the time is going to be used by the browser. What happens if it is beyond 16 milliseconds? Your frame gets dropped, and that's not a good thing. So you need to make sure that you're always checking this. So do you want to see an example of this? So here's an example from CNN.com. And the way you check this is, you go to your performance tab and look for these red signals. They recently changed this, so I'm going to try this. All right. So if I were to pick any of these red bars, I could come in here and hover, and you see it's 5 frames a second. That's really bad, right? Now you can come in here and go here, and you can just try this, and it will be like 1 frames a second here. There's really nothing going on there. 1 frames a second. And this is how you can check your entire code. Actually, it just happens to be that particular segment that we're not even getting anything that's good. So that's an example. Here's where you can find out your frames and then get more details about it. And you can also dig deep into it, where exactly you're having that issue, right here, and work with it. But this is one thing I would do. Maybe part of your testing. Now, speed is a feature for us. A lot of times, speed, it just happens to be one of the things, right? Performance has to be a feature. It has to be part of your agile, chart. Basically, like, okay, well, here's a story on performance. And that's where you might want to take care of a lot of these things. So how does layout work? So when you're resizing, you're adding or removing nodes, you're changing styles. At that point of time, you're also changing the layout. So let's look into this. That was a simplified view of a frame. But let's take an example like this. So for example, you have elements, and you're going through elements, and you say, all right, element.style.left equals element.offsetLeft plus 1. What do? We're making changes here. First, we're actually querying this value. Then second, we're updating this. When we update this, it's forced to actually paint. So this layout is now forced. So what's happening? If you look at the color green, that's the layout, right? So I've got my code, and then I've got my layout, then I got my code, then I got my layout. Imagine this happening, let's say, 100 times. Now I'm doing that here, right? And it's a very expensive operation. And then finally, paint's going to happen. So this is not a very good thing. So when you're applying your visual styles, really you create the bitmap and then you pixelate the screen, and that's really paint, right? So the previous one was layout. This is the paint process. So what do you want to do? You want to update the minimum area that's needed and then make sure that some styles that are more expensive, we take care of them in a different way. We'll look into some examples. So something like this is a very bad idea because it's actually doing reflow, which we'll talk about in a second. So we're doing that 1, 2, and 3. So we're doing it 3 times. Now this is expensive because we're forcing a layout. We're forcing a paint. A better way to do the same thing would be take something like this. You have a style and then you have a CSS text, or even you can even have a class name here and say, well, add it to the particular class. And then you can add a colon, semicolon here, and then add the style to the class, or you can override a class, or you do something else. But now we have everything in one line, and this is going to be one operation to paint the same exact thing, right? A lot of code like this is everywhere. I mean, you just go to almost every website out there, right-click on the view source, and you'll get a lot of code like this. But it's an expensive operation. The best thing with HTML5 is that we have the same spec across all browsers. So previously, there was a lot of difference, but now most of them will handle it in the same exact way. I'm talking about the primary browsers. So it's very predictable. Here's another example. This is inefficient because here's what I'm doing. I'm getting an offset left, adding pixels to it, and then I update that value right here. So I'm also looking for that value, and then similarly, I update it, and then I do the same thing here. And then if I'm checking for this particular value, which I've already used here, so what should I really do? I should cache that value. Because why would I want to look this value up every single time I'm using it? That's a really good pattern in JavaScript in general. Anytime you're doing this, for example, document dot, get elements by tag name, and you have a bunch of elements, what you don't want to do is take that and then look for element number 9 every single time you do that. What you want to do is take that value, put it to a local variable, because that's now cached. So this needs to go in a local variable. That's the first thing. So we take this out. We create a local variable. So now we're not doing a lot of lookups. And then we can say left is this, and then top is that. And now we're checking for this, not this. And that's how you're saving performance here, right? And then if it is greater than 500, do something with it. So most expensive part of the entire process here is paint. So what do you want to do? You want to make sure that you use it the least amount of times, right? Anytime you change a property, it's going to trigger a paint. Now keep in mind, layout automatically triggers paint. So anything we did right in case of layout needs to stay with us, because if we change the layout, paint's anyways going to happen. Now, it can also trigger paint without layout. If you change the background, you change the text colors, you change shadows, so they're a little bit more expensive. So shadow is a little bit more expensive than a regular style for that particular reason. So reduce the paint area. One good way to look at how to reduce the paint area is, now that takes forever. All right, so we go back here. Let's say you have a game, right? This is where you can see it. So you go to these tools, go to more tools, and then go to rendering, and this thing pops up, and then you click paint flashing. So you can see if I remove this, the green color is going to go away. So what's happening in this game is that the entire block is getting rendered. In fact, the entire page is getting re-rendered, which is not a very good idea. So let's just go to something else. Let's say google.com. Actually, let's just do it right here. So in case of google.com, you can see that the green layer is just over there. So that's the only thing that's going to change. So that's the only segment that changes. Whereas in the previous one, you had the entire page re-rendered every single time. And not a very good idea, right? So those blocks, you can identify those blocks in your code and then work on fixing those one by one. So reflow. Let's talk about reflow. Whenever you resize a window, this is going to happen, right? So when you're resizing a window, let's say you have one render tree, and you resize the window. Let's say you go from a tablet view to a mobile view. This is going to happen, right? When you change a font, this is going to happen. When you change certain classes, like hover, change the class attribute, you can also calculate offset width, height, and this is still going to happen, and reflow is very expensive. When reflow happens, what happens next? First of all, if reflow changed an element, it's going to change all the child nodes. It's a really bad thing. Second, it's also going to talk to everything that's following it, and it's going to reflow the entire thing. So it's repainting that entire thing. So it's not a very good idea. Effectively, the entire page is re-rendered after that element. So there are certain ways you can prevent that. Now, we remember that one thing we talked about was that if you have something as display none or it's hidden, it's not part of the render tree. And anytime you work on something that's not part of the render tree, reflow won't be triggered. So what you could do is change the visibility to hidden, work on it, and then replace it back and say visibility block. Very smart technique, but you've saved a lot of your overhead. Your performance is going to increase drastically. So let's take an example for reflows. You can also use a fragment. So you go to document.create a document fragment. You take that fragment and say, OK, here's my element, which is P, and I have contents of that element. I've got all of that. In my fragment, go append that particular DOM element now. And then append that fragment to the DOM. This way, we didn't manipulate the DOM. And we did not cause reflow to happen, which was actually the more expensive operation. So this is another way of doing the same exact thing. You can also clone that particular element. So for example, you have container, and then you clone the original element, work on it. Once that's completely done, replace it back right here. And you can do the same exact thing. Keep in mind, it only is a problem if you're working with something in the DOM. If you're working with something in memory, it's not a problem. But these are very simple things. You know, a lot of times you look at this code, you can oversee it because your junior developer might not know what he was doing. But these are certain things that you want to talk to everyone in your company in a brown bag session and say, look, we have a policy, we're only going to do this. And you can show how expensive it is by just showing one of the Chrome developer tools or any other browser you use. So here's another one that I talked about where the display was none. We make some changes, and you can do any amount of changes, by the way, here. You can actually go and do another 10, 15 lines. It's not going to make any difference. Remember previously, we had 3 styles, and I said we don't want to do it 3 times, so let's get into a class. In this case, what I'm saying is it doesn't matter. It could be any amount of changes at this point of time. You can have 10, 15, 20, doesn't really matter. Once you've done all of them, all you're saying is display block. So you can choose any of the 3 techniques, right? One thing you have to remember about the document fragment is if you have a form, you can get into issues with it because there's a lot of things going on in an actual form. So be careful with that approach. Thought leaders to follow, they're really good people. They've got a lot of free content out there. I think more important than any books that you want to read, because most of them are actually outdated, these are the right people to follow. Maybe take a picture of this, and you can take my picture if you want. I'm kidding. And yeah, I mean, there's got a lot of good stuff. And then books, you've got Computer Networks by Tenenbaum. I highly recommend it. I read it during my master's. It's very, very good. There's a lot of good stuff that you still don't find anywhere else. It's got the 5th edition now, you know, and it's updating. Ilya Grigorik has written a very good book. I think there's a little bit of overlap there, but this book is still worth reading. A lot of good stuff, especially about networks. As a developer, you might not have ever gotten into networks as much, especially if you're not done computer networks as part of your courses. A good refresher, and he's updated the content quite a bit. It's also, I think this one is available online for free. High performance JavaScript. A lot of what he talks about is great for when he wrote the book. I would highly recommend testing a lot of things because at this point of time, browsers have got better. So a lot of times you'll see is like he'll give you ideas which I think are good ideas, but at the same time, those things have been fixed in most of the browsers. So when you read this book, I would also do my own testing. And then high-performance websites, and I think he's got a second book too. So this was 2008, I think, or 9, and then later he comes up with another book, which I think is another really good book, where he has a lot of updates. Whatever you see here is great, but then he's added a lot to it later, and we touched upon a lot of those concepts too. All right, so let's talk about some code, because we have some time, I believe. How much time do we have? We have 10 minutes? Perfect. All right. So let's take an example here. I've got something called an car object. It has images.length. A lot of times you'll see this in your loops. And keep in mind, loops are not always 10. I've seen loops that are sometimes 10,000, which unfortunately exist in a lot of actual code. So what you want to do is do something like this, where you get the images. Now you have car.images, because imagine, in this case, you're always making that call, even though you're part of the same loop. The values shouldn't change, but you are assuming that they might. And that's why you're looping through it. So once you cache that object, everything else becomes easy. So that's a typo. It should be images.length. And sometimes you're even better off caching the length. You can just take the length out. Why do you want that length to be calculated over and over again? So really what you do is var images equals car.images, and then you can do images.length equals to images.length, I is less than length, I++, and then do whatever you want to do here. So that's a little bit more efficient. Another one, I just talked about that. So second example is just building on the first example, where now I'm caching the length, and now it's less than len equals to x.length. You could do it part of the loop, you could do it outside the loop. Inspection time. So for example, here you have elements, and you are trying to get all the elements. This is not a very good thing, because it's a star, and assuming your DOM is big, this is a disaster. So here you have all elements, and then you're going to loop through all the elements, all.length, and then if that particular guy has that particular attribute, then do something with it, right? So in this case, what you could do is document.getElementById, and go for that particular ID, and then get elements by tag name. Now, I'm not a big fan of stars anyways, because if you really have a way to locate what you're looking for, you can also say, well, maybe it's a div. But if you know it's a div only, or it's multiple things, you're better off doing that rather than a star. But the point here is that you're trying to zero in and reduce your overhead by making a smart decision up front about what exactly that element could be. If I already have the ID and then I know the tag name, which is a div or something, then I have a much more specific search, and it's going to be having less overhead. So var I equals 0, I is less than length. I mean, it's same exact code, and it works perfect. XPath. Now, XPath is actually faster than going through the DOM. So if it's supported, you're better off using that. Sometimes it could be twice as fast, right? So that's another thing that I would look for. Not all the time you need it, because you could actually cache the DOM and use some of the techniques that we used previously, but it's also available there. There's more detail here. That was the source. And then avoid keeping alive references. This is a very important thing. A lot of times in JavaScript, we keep things alive that we shouldn't. And that's very important. So for example, you have an iframe, or you have something else, right? Now that's a remote document, and you also have now a reference to that particular remote document. And then you did something with it. You got the element by ID, you got the content, and you have the remote container. And then you created the element, and then you appended the child, and then you clear your text node, and you add that content, and now you're really done with it. You got to make sure that you do this at this particular point of time, right? Making it null. Now, a lot of times people also use delete keyword to delete these, and sometimes they do nulls. So I'll tell you only one pointer there. If you actually go on your regular global scope, I'll just show you that example in code. So let's say you're here and you've got some kind of script going on, and you are in the global scope. And if you do var x equals 10, just s equals 10, and var y equals to 20. Can anyone tell me what's the difference? Oh, sorry. Can anyone tell me what's the difference now? I was like, oh, it's an S and a Y. Is that what you're looking for? So London is amazing, and for the last 3 days, I've been sleeping around 4 p.m. And today I was supposed to talk. That's called jet lagged. Anyone difference? Why? They're both global. That's actually a trick, because a lot of times you'll think that one is global, right? They're actually both global because they're part of window object right now. If they were in a function, then it would be a different story. But currently they're both global because they're part of script. Anything else? Wild guesses? It's not an easy one. So I'll show you this. So we're going to do S, and then we got Y. Thanks. Can anyone tell me what's the answer? We're going to print 4 things. What do you think are the values? All right, let's try this. You see that? Y is not defined. But I was able to print S second time, even after deleting it. So what's amazing is that I've asked this question in more than 25 different cities in 5 different continents of the world. No one gets it right. That tells you something about JavaScript. It is not you. Trust me. This should not be this way. Let's put it that way. So here's what happens. If you actually use a var, and in this case, you had used var with S, and it said Y is not defined because Y got deleted, but S didn't get deleted because you used a var. If you use a var in the global scope, you can't delete that particular object. It's interesting. So that's why I use the approach in that case to say S equals null in the last slide. I did not say delete S, because that's, I'm not going to call it bug because this is the specification of ECMAScript, right? So, but this is one thing you need to know. Now imagine you had a really big DOM element, like an object with, let's say, 35 different tables. That's not possible. Only 32, right? Anyway, something that big. You can't delete it. And that's good to know, right? So what you could do is either make it null or even make it empty string, whatever. I prefer null. That's what I would do. Cool. That's it. Any questions? Yes. Right. So the problem with Reflow is it's an expensive operation, and it's going to re-render everything every single time. So Reflow, anytime that's being called, it's a better technique to use something else. Now cloning, I know it's a big thing in that case, right? So that particular example is not the best example. But what you could do in that case is just hide it, and then convert it back to block. Simple. It totally depends on where your object is placed. Let's say you are the last thing on the page, then you're perfectly okay. But if you're somewhere in between, then you're re-rendering the entire page pretty much, right? So even that one reflow is really bad. So I would not do 2, because it'll happen very quickly twice. Oh yeah, every single time. But if you clone it the way I explained, it's only going to happen one time. Okay, so for one property, that might make sense, but for 2, it may not. So question, does everyone know what the question is? So the question is that, do we do it, whenever the reflow happens, it happens just because we did something, as in we changed the style element or whatever. And what is that threshold. So basically, like, do we wait if we have 3 different changes to be made and we do it that way, or we just do it every single time, right? So I would still go with the same approach that if you have style changes, then do the first thing that I showed, which was don't worry about anything, just one time create a class and add all those styles in a line and then push it over. That'll be my first approach, because that doesn't require you to do hidden or any other thing that I showed, because there are 3 other ways you could do it, right? So for anything small like that, do something like this, which is very simple. You don't need to do hidden. You don't need to do fragmentation or anything else, right? Now, what's the second approach? Where you really want to deep clone the object because there's a lot of changes you're needing, right? In that case, that's perfectly okay. So that's my take on it. I would not overdo it, right? But remember, every single time you have that line, it's reflowing the entire thing, which is a very expensive operation. And if you have that pattern in your code, you want to kill it and let everyone else know that do not do it, because you might start with 1, but someone else might pick it up and add few things, and now we have another problem. Because you can't always look at the entire code, right? I mean, it's 2 to 5 million lines of JavaScript code average in newer applications now, so I can't personally check the code my team is doing with 200 other people. Any other questions? I'll stick around, but you are a very amazing audience. Thank you so much. Have a good day.